Ever wondered how Mars looked like in its surface? Mars, a dusty cold desert world with a very thin atmosphere, has seasons, polar ice caps and weather and canyons and extinct volcanoes, evidence of an even more active past. Mars is one of the most explored bodies in our solar system, and it's the only planet where we've sent rovers to roam the alien landscape. Take a look at the evidence found by the robotic explorers that Mars was much wetter and warmer, with a thicker atmosphere, billions of years ago. Mars, a closer look. High Dune, first Martian dune studied up close. The rippled surface of the first Martian sand dune ever studied up close fills this view of High Dune from the Mastcam on NASA's Curiosity rover. This site is part of the Bagnall Dunes field along the northwestern flank of Mount Sharp. The dunes are active, migrating up to about 1 yard or meter per year. Vera Rubin Ridge, Mount Sharp, Mars. The redder rocks of the foreground are part of the Murray Formation. Pale gray rocks in the middle distance of the right half of the image are in the clay unit. A band between those terrains is Vera Rubin Ridge. Rounded brown knobs beyond the clay unit are in the sulfate unit, beyond which lie higher portions of the mountain. Strata, at base of Mount Sharp. A view from the Kimberley Formation on Mars taken by NASA's Curiosity rover. The strata in the foreground dip towards the base of Mount Sharp, indicating flow of water toward a basin that existed before the larger bulk of the mountain formed. Resistant feature, Pahrump Hills Outcrop. These features on the Pahrump Hills Outcrop are accumulations of erosion-resistant materials. Similar appearing features on Earth form when shallow bodies of water begin to evaporate and minerals precipitate from the concentrated brines. Rock, meteorite on Mars. The meteorite is about the size of a golf ball. Iron-nickel meteorites are a common class of space rocks found on Earth, and previous examples have been found on Mars, but rock is the first on Mars to be examined with a laser-firing spectrometer. Bone up, on Mars rock shape. This Mars rock may look like a femur thigh bone. Mission science team members think its shape is likely sculpted by erosion, either wind or water. If life ever existed on Mars, scientists expect that it would be small simple life forms called microbes. Martian rock Harrison, showing crystals. Harrison, the elongated crystals are likely feldspars, and the matrix is pyroxene dominated. This mineral association is typical of basaltic igneous rocks. The texture provides compelling evidence for igneous rocks at Gale Crater. Shaler Units, evidence of stream flows. This stratigraphic unit is called the Shaler Unit. Decimeter scale cross-bedding in the Shaler Unit is indicative of sediment transport in stream flows. Currents mold the sediments into small underwater dunes that migrate downstream. When exposed in cross-section, evidence of this migration is preserved as strata that are steeply inclined relative to the horizontal, thus the term cross-bedding. The grain sizes here are coarse enough to exclude wind transport. Mount Sharp comes in sharply. The foreground, about 2 miles or 3 kilometers from the rover, is a long ridge teeming with hematite and iron oxide. Just beyond is an undulating plain rich in clay minerals. And just beyond that are a multitude of rounded buttes, all high in sulfate minerals. The changing mineralogy in these layers of Mount Sharp suggests a changing environment in early Mars, though all involve exposure to water billions of years ago. Link to a watery past. A rock outcrop called Link pops out from a Martian surface that is elsewhere blanketed by reddish-brown dust. The outcrop characteristics are consistent with a sedimentary conglomerate, or a rock that was formed by the deposition of water and is composed of many smaller rounded rocks cemented together. Water transport is the only process capable of producing the rounded shape of clasts of this size. Stick shape, rice-size features on Martian rock Haroldswick. The dark, stick-shaped features clustered on this Martian rock are about the size of grains of rice. The origin of the stick-shaped features is uncertain. One possibility is that they are erosion-resistant bits of dark material from mineral veins cutting through rocks in this area. Strathdon, and ancient sediment. This mosaic of images shows a boulder-sized rock called Strathdon, which is made up of many complex layers. Mosaic of images shows layers of ancient sediment on a boulder-sized rock called Strathdon. Rock outcrop Missoula. Pale mudstone, bottom of outcrop, meets coarser sandstone, top, in this geological contact zone. White mineral veins that fill fractures in the lower rock unit abruptly end when they meet the upper rock unit. Such clues help scientists understand the possible timing of geological events. M9A, Murray Buttes. The site is in the scenic Murray Buttes area, where individual buttes and mesas were assigned numbers. This one is M9A. Stimson Formation, Murray Buttes. The buttes and mesas rising above the surface are eroded remnants of ancient sandstone that originated when winds deposited sand after lower Mount Sharp had formed. Curiosity closely examined that layer, called the Stimson Formation, during the first half of 2016, while crossing a feature called Outcrop Plateau between two exposures of the Murray Formation. The layering within the sandstone is called cross-bedding and indicates that the sandstone was deposited by wind as migrating sand dunes. High Dune, a Martian sand dune. High Dune, in the Bagnall Dunes field skirting the northwestern flank of Mount Sharp, is the first sand dune studied in place anywhere except Earth. This view of the undisturbed surface of a Martian sand dune called High Dune visited by NASA's Curiosity rover shows coarse grains remaining on the surface after wind removal of smaller particles. Garden City, Vein Complex. Mineral veins such as these form where fluids move through fractured rocks, depositing minerals in the fractures and affecting chemistry of the surrounding rock. In this case, the veins have been more resistant to erosion than the surrounding host rock. Types of vein material evident in the area include 1. Thin, dark-toned fracture-filling material, 2. Thick, dark-toned vein material in large fractures, 3. Light-toned vein material, which was deposited last.